Let me first of all begin with my information. I am Dr. Jigar Patel. I'm going to coordinate this course and I'm going to teach this particular section. Um, for the first 10-15 minutes, we are going to discuss a basic structure of this course. And once we have that structure clear, I will try to recall some of the topics that many of you should have seen in the past. Now, before I go any further, let me mention here that if there is anything that doesn't make sense while I'm teaching, please don't hesitate to um, ask me a question. All right, you can ask your question by typing your question in the chat box, or you can turn on your mic and ask the question. All right, feel free to do that. This will be like a discussion between you and me, and I wanted to make the discussion as healthy as possible. All right, um, I am going to use two things for these lectures. All right. So first, I'm going to use the slides that I prepared, and then number two, I'm going to use that whiteboard to show you the example. Most of you must have noticed that I have posted the first week's lecture notes on this course homepage. What I want you guys to do is download that and then print it. If printer is not available, if you want to work it out on your iPad or Surface or whatever, feel free to do that too. But what I recommend you guys to do is when I'm solving the problem on the board, I want you guys to write down the solution on that lecture handout that I have posted there. Now the lecture handouts, they are not completely blank document. It contains, theory, main definitions and remarks. And then after each example, there is a space to write down the solution of that example. And as I said, I want you guys to write down that solution with me to understand, to grasp this process carefully. All right. The course will be very simple and straightforward. If you attend all the lectures and participate in most of the items, you should not have any difficulty passing this course. All right. Um, Now, let me start um, by giving you the basic structure of this course. This course has three main components. I'm going to explain you all these components briefly very soon. But first and foremost, let me mention here that when you log in to e-learning, you should be able to see two links that says Math 1325. The first link will have Math 1325.008. This is our lecture section. This is the section that we are going to use to deliver the lecture and do the question answer. All right. So we are in section 008 right now. All right. So for lectures, we are going to meet. We are going to use this section 008 link. There is this second link that says Math 1325.7W1. This is the exam section. We are going to communicate gradable items using this particular section. All right. So for example, all your homeworks, quizzes, and other items that needs to be submitted on that 7W1 section. All right. Any homework should be accessible through that 7W1 section. You will be able to get your grades for the assignment on that section. Basically, we are going to use this 008 only for lectures and posting the notes and videos. All right. All these lectures are going to be recorded and I'm going to post these videos on Microsoft Streams. So if you want to go back and rewatch the video to gain better understanding, feel free to do so. All right. So by the end of the day, I will release the videos. To access the videos, all you have to do is go to your lecture section, click on the Microsoft stream on the right side, and then it will take you to, you know, the lecture video immediately. Okay. All right. So as I said, without wasting any time, let me give you a brief idea of three major component of this course. And I'm going to show you this on the board. I, of course, want you guys to carefully read the syllabus and let me know if you have any questions. But here is a brief summary of some main ideas, main components that we are going to use in this course. So as I said, there are three main components. This is Math 1325. The first of our applied calculus sequential courses. Many of you are going to take Math 1326 as well, which is the second part of this course. As I said, this course is divided into three components. The first and the most important component is homework assignments. All right. There are two types of homework assignments that I am planning to give on a weekly basis, except for the exam week and the first week. Right. So, sorry, first week there will be homework, but it's not. There is nothing due this week. All right. There are two types of homework assignment that we are going to use in this course. The first one is a traditional paper homework assignment. We are going to call them PHWs. All right, paper homework assignments. I'm planning to post one paper homework assignment every week on that exam session. The first PHW is already posted there, and it contains material that we are going to cover during this week. What you guys need to do is you need to download that document, you need to print it, and you need to solve all the problems and upload it back at the same place by next Tuesday, end of the day. All right. So after next Tuesday, the system will no longer accept submission. Right. So 11:59 is Tuesday. 11:59 p.m. is the deadline for paper homework assignments. This is the shadow. This is going to be the shadow of what we are going to do in the lecture, in the live lecture. All right, and I want you guys to participate in all of them. Trust me, if you feel confident with this particular component, then your grade will be decent at the end of the semester, because the quizzes and homework, they also shadow the paper homework assignments. There will be 12 paper homework assignment we are going to release. One lowest paper homework assignment grade will be dropped. So in case if you miss one paper homework assignment due to the health related issue or any other issues, you don't have to worry about it. One lowest grade will get dropped. This paper homework assignment, it contributes 15% towards your final course grade. As you see, it's very important, right? 15% of your final grade, it is coming from the paper homework assignment. And as I said, I encourage you guys to, participate in all of them. Okay. The second type of homework assignment is called digital homework assignment. In short, we will be calling them DHWs. This is the set of homework that I'm planning to post on the third-party website called MyMathLab. To access this homework assignment, you will have to follow the instruction given on the syllabus. All you have to do is click on the exam section. On the home page of the exam section, you will see a link saying Pearson MyLab Mastering. Click on it, follow the instruction, and then it will take you to the Pearson website. I believe Pearson, they give you 14 days grace period. The first digital homework is already posted. Want you guys to, start working on it. So after the grace period, they will ask you to buy the access code, which will grant you the access to the full set of homework assignment until the end of the semester or until the end of the year or whatever, right? Uh, but again, follow the instruction to get full access. If you don't want to purchase full access right away, perfectly fine. At least get that trial period. Get in. Use that 14 days trial period first, and then uh, then buy full access. All right. Like the paper homework assignment, the lowest score will get dropped. So at the end of the semester, we are planning to, drop one lowest digital homework assignment score as well. And this is going to contribute 5% towards your final course grade. All right, so that's altogether the first component of the course out of three with the appropriate weightage. Okay, the second and the most important component is weekly quizzes. All right, I'm going to post the quizzes and I will keep them open for 1 hour period for you guys to work them out on a weekly basis. I would like to give you two options here. The first option is a default option, and the second option, if you need the second option, you need to send me an email. All right. So let me give you those two options first. All right. We have two options for quizzes. Option number one is Thursday. Quiz will get released at 7 p.m. All you have to do is download that quiz, solve the problems, scan it, and upload it back. If you don't have a printer, perfectly fine. You can write down your solution on a separate sheet of paper, preferably one problem per page. All right. And you can be sure you write down the problem number carefully so that it's easily gradable. You can do the same thing with paper homework assignment too. All right. If printer is not available, write down your solution on a separate piece of paper, one problem per page, and then scan your work, submit it, upload it. Perfectly fine. So this is the first option. As I said, it's a default option. If you don't like the second option, you will be taking the quiz during 7 to 8 p.m. time window every Thursday. The second option is might be more convenient for many of you. 15 minutes after our class ends, right? So our class ends at 11:15. So the quiz starts at 11:30 a.m. to 12:30 p.m. Again, if you want that second choice, if you prefer that second choice, all you have to do is send me an email and I will make sure that the quiz gets released to you around 11:30 every Thursday. All right. Okay. So again, if you are happy with 7 to 8 p.m. every Thursday, you don't have to do anything from your side. Okay. Every Thursday, 7 p.m. quiz will be released automatically. If you want this time, send me an email. If none of them works, send me an email and I'll give you, you know, another option. Okay. But this is again something that we are going to do on a weekly basis to prepare you for the exam. Trust me, these quizzes are going to prepare you for the exam. It will keep you active. It will keep you working on the material on a weekly basis. Okay. All right. And third, and the final component of this course, as you can imagine, it's going to be exams. All right. Two types of exams we are going to give out to you. The first type is pretty standard. You'll have two midterm exams. As I said, there are two of them, midterm 1 and midterm 2. All right. So we will have two midterm exams. Let me tell you their weightage as well. Between the first and second midterm, whatever is the best, it will count 20% towards your final course grade. Now, this is something that we did to benefit the students. If let's say if some student get bad score on one of the exam, then he or she will not be punished badly. All right, you always have, another go to give your best shot on the remaining exam. The second best or the lowest score between these two will count 15% towards your final score. All right, so between two midterms, we have a different weightage, but this different weightage is going to work in your favor. All right, so best one will count 25%. The worst between first and second midterm score will be 15%. And then finally, the last piece in this exam component is comprehensive final exam. And this is 25%. All right, final exam will be cumulative. It will be, even though it's cumulative, I would say more preference will be given to the material covered towards the end of the semester. All right. As we approach close to the final exam, I'll give you more detail about it. But this is more or less the rough skeleton of all three important components of this particular course. And trust me, if you participate, if you attend lectures regularly and participate in all of them, then the course will be pretty simple to clear with a very decent grade. All right. So again, that's the rough idea of what how the course will look like, and I encourage you guys to read the syllabus carefully and let me know if you have any question about any of this component, and I'll be more than happy to go over them with you carefully. All right, now without wasting any time, let me tell you what I would like to cover in today's lecture. In the first 2-3 weeks, let's talk about the course first. In first 2-3 weeks, we are going to review some selected topics from algebra. Many of you may have seen basic algebra in your high school or in your college algebra course, right? What we would like to do here is we would like to handpick few interesting ideas and topics that you will be using repeatedly in Math 1325 and Math 1326. All right, so this review is going to be very, very crucial and very, very important. It's vital for your success. All right, and I recommend you guys to, uh, do as many examples as you can. All right. Okay, so as I said, first 2 to 3 weeks we will be spending on the review from for the selected topics from basic algebra course. We will introduce the notion of a function, and then we will get into the calculus. All right, we will learn what are the main processes in calculus and how to apply them on the given function. At the end of the semester, you will have a chance to see some fascinating applications of calculus in the real world. All right, why this course is useful. We are going to address that towards the end of the course. All right. Okay, so as I said, without wasting any time, let me go to the today's material. Today, I would basically like to cover four interesting things, right? The first one will be the order of operations. Now, this is really kind of a simple set of rules that you need to follow in order to simplify any expression that is given to you. Now, remember, uh, think about it in very simple setting. If I give you a long mathematical expression that involves addition, multiplication, division, subtraction, powers, parentheses, and everything, right? How would we solve it? Again, there is a rules that we need to follow in order to simplify the expressions, and we are going to discuss those rules carefully. Many of you may know these rules already, but still, I just wanted to recall them because we will be using these rules throughout the semester. Okay. Once we have the idea about order of operations, I would like to define terms and polynomials. All right. In a very logical way, we are going to define these two things. Trust me, everything will be very nicely connected and you should be able to see the connection. Okay, so there will be no discontinuous pieces. Everything will be connected so nicely that you will be able to see it as a one piece at the end of the semester. Okay, all right. Once we have the idea of polynomials, we will be answering question like, if I give you two polynomials, can you add them, multiply them, subtract them, divide them? Right? So basic operations on polynomials is what I would like to talk about. And then if we have a time, I will get into the idea of factorization of polynomials. Now remember, addition, multiplication, and subtraction of two polynomials. These three processes, they are simple process. Dividing two polynomials needs something extra, right? And that something extra is factorization. And again, we will be going into this discussion in a very logical manner. Okay, these are all items connected to each other. So let's start with the first item, order of operations. So if you have, let's say, all the operations together present in one long expression, how would you simplify it? For example, you have addition, subtraction, multiplication, division, powers, many set of parentheses. How would you handle such expression? How would you simplify such expression? I would do the following. Always start solving the expression starting from the most inner parenthesis. Again, if there are multiple sets of parentheses involved in the expression, you would like to start simplification starting from the most inner set of parentheses. All right. Okay. What do we want to do inside the most inner parenthesis? inside the most inner parenthesis, I want you to calculate the powers first. So inside the most inner parenthesis, if you have something like 2 to the power 3, I want you to compute that power first. 2 to the power 3 must be calculated first. All right. So in the most inner parenthesis, compute powers first. Then multiplication and division. All right. Once you compute powers, then compute multiplication and division. Simplify multiplication and division. And then at the end, simplify addition and subtraction. All right. So we need to follow this particular set of rules to simplify any expression. All right. So if you have a long expression contains multiple set of parentheses, I would try to find out the most inner parenthesis. Inside the most inner parenthesis, I will be simplifying powers first, multiplication and division next, and then addition and subtraction at the end, and done. And then I will open the parenthesis gradually. Okay. So again, that is the idea that we need to implement in order to simplify expression. To demonstrate this process, I would like to show you two examples. All right, so this is example number 1 with two sub-problems. It says use the order of operations to simplify the following expressions. I know that many of you can solve this thing in 2 or 3 lines. It's perfectly fine. As I said, my goal is just to demonstrate how this order of operation works. So let me show you the solution of both of these problems on the board. And as I said, want you guys to copy the solution on a separate sheet of paper or in the lecture note for the first lecture where you have a space given for both problems. All right. So let's try to do this on the board carefully. Okay. So let me clear this first. All right, so I'm going to copy both sub-problems side by side. Here is the first one. I have in the parenthesis 2 times 6 minus 3 the whole square minus 4 times 1 plus 3 minus 2 minus 2 to the power 3 entire thing to the power 5 minus 5. And then the second expression has 5 times 1 plus 2 square minus 4 times 7 plus 5 the whole thing to the power 3 minus 7 over 3 times 1 plus 4 minus 3 times 2 to the 2 minus 1. All right, so these are the two problems that I would like to simplify using the proper order of operation. All right, so remember, first thing first, find out the most inner set of parentheses. All right, looks like we have 1, 2, 3, and 4 parentheses. There are 4 sets of parentheses involved in the first example, right? Look at that. The first one, second, third, and fourth, right? So the first one is the outer parenthesis. The remaining 3, they are the inner parentheses. All right. Remember to start simplification with the most inner parenthesis. All right, so I am going to simplify this three expression inside the most inner parenthesis first. What do I have to? What order do I have to follow inside that most inner parenthesis? Power should be calculated first, multiplication and division next, and then addition and subtraction, right? Let's check. Inside this first inner parenthesis, what sort of operation do I have? Do I have any powers? Answer is no. Do I have multiplication and division? No. Do I have addition and subtraction? Well, there is a subtraction, 6 minus 3. So I only need to perform subtraction to simplify the expression in this first inner parenthesis. How about the second inner parenthesis? Well, no powers, no multiplication and division, only addition and subtraction. So all I have to do is perform addition and subtraction here. Inside the third parenthesis, no powers, no addition, subtraction, no multiplication, division. All right, meaning this is already in its simplest form. Let's try to simplify each of this expression in the most inner parenthesis. Look, 2 times 6 minus 3 is 3 to the power 2. 4 times 1 plus 3 is 4. 4 minus 2 is 2. Minus 2 cube. All right. Okay. So now we have simplified expression in the most inner parenthesis using the rules. Power should be calculated first, addition, multiplication next, and then division and, powers, multiplication, division, and then addition, subtraction. This is the rule that we have used to simplify expression in each of the inner parentheses. Now it's time to simplify expression in that outer parenthesis. Remember, power should be calculated first. All right. So let's compute the powers first. Look at this. We get 2 times 3 to the 2 is 9. Then 4 times 2, I'm leaving it alone for now. And this is 2 to the 3. 2 to the 3 is 8. I know that many of you can skip a couple of steps here, and that is perfectly fine. I just want to demonstrate how this idea looks like. Right? Okay, so now all the powers have been calculated. Now multiplication and division. Look, I have multiplication here, and this is good. Look, 18 minus 8 minus 8 to the 5 minus 5. All right. Remember, I calculated powers first to simplify expression in that outer parenthesis, and then I did multiplication next. Now addition, subtraction. 18 minus 8 minus 8, that is 2. All right. 2 to the power 5 is 32. 32 minus 5 is 27. And that is really the end of the story. This is how we can simplify the expression using proper order of operations. Okay. All right. Let's apply the same thing in here. The most inner parenthesis has addition here, addition here, addition here. I'm gonna use that operation first. So 5 times 1 plus 2 is 3 to the power 2. 4 times 7 plus 5 is 12. The whole thing cube minus 7. 3 times 1 plus 4 is 5. 2 square is 4 minus 1. All right. Okay. So for this parenthesis, I need to compute the powers first. Then I will take care of multiplication and then subtraction. Okay. So I'm going to write down one additional step here. 5 times 9, 4 times 12, 3 times 5, it's 15. 3 times 4, that's 12. And then minus 1. Let's simplify this now. Multiplication. 9 times 5, 45. 12 times 4, 48. All right, so 45 minus 48 is negative 3. And then 15 minus 13 is 2. Negative 3 cube is negative 27. Yeah. If you simplify, you get negative 34 divided by 2, and you end up getting negative 17. All right. So again, understand that there is nothing complicated in any of this solution. These are literally like demonstration problems to show you how order of operations can be used to simplify any expressions. Trust me, you will be using this order of operations so frequently in this course. All right, so the more example you practice, the more confidence you will get. All right, fairly interesting and straightforward idea. Yeah. Okay, so now let's move on and let's go to the next item. Remember, I asked you to, I told you that we are going to discuss terms. All right, so let's try to understand what do we mean by term. This is the word that you are going to hear many times in every single lecture. Okay, so let's try to understand what do we mean by a term. All right, a term is an expression of the forms a times x to the power n. Very simple definition. Look at this. Term is an expression of the form a times x to the n. Okay. Now, understand there are three things in here. A, x, and that n. I would like to give them a name. Okay. So again, there are three things that I have in here, and I'm going to give them a name. Okay. I'm going to call that A coefficient. X is a variable and n is exponent. All right. So again, I'm sure that most of you know, perhaps all of you are aware of these wordings. I just wanted to recall that idea before we move further, right? So A is the coefficient, X is the variable, N is the exponent. Okay, so we know what do we mean by term, and we also know how the term would look like. Okay, now here is the next question. If I give you two terms, would you be able to compare them? Again, understand the question. If I give you two terms, again, the typical term should look like this. Let's say 3x to the power 7. Right? This is a typical example of a term. What is the coefficient? Coefficient is 3. What's the variable? Variable is x. And what is the exponent? Exponent is 7. Right? Let's say I have 7 q to the power 8. What is the coefficient here? Coefficient is 7. What's the exponent? Exponent is 8. And what is the variable? Variable is q. All right. So it's very easy to visualize the term. What I am saying is this. If I give you two terms, is it possible to compare them? Think about it in a simple setting. All right. If I give you two numbers, 7 and 10, right? Immediately you will compare them, right? 10 is bigger than 7. That's the immediate thought, right? So can we do something similar for the terms? If I give you two terms, is it possible to compare them, right? Answer to this question is yes. All right, and I'm going to answer that question in terms of two remarks. Remark number one: two terms are like terms if they have the same exponent and same variable. So I want these two features to match. Two terms are like terms if they have the same variable and same exponents. Okay. If this is not the case, then I call two terms unlike terms. All right. So again, two remarks, fairly simple, right? Like terms are the set of terms that have same variable and same exponent. If this is not happening, then you call the terms unlike terms. All right. You may wonder that why are we interested in this? Well, the reason is here. For two like terms, they can be simplified further in terms of their addition and subtraction. Okay, so again, a very crucial remark. Like terms can be simplified further in terms of their addition and subtraction. Okay, so for example, if I give you two numbers, 2 and 5, I ask you to add them. 2 plus 5 is 7. You see, we can simplify two numbers. Now, if you have two like terms, 2x cube and 5x cube, if I ask you to add them, 2x cube plus 5x cube, you add them exactly like how you added two numbers, 2 and 5, right? 2 plus 5 is 7. Likewise, 2x cube plus 5x cube is 7x cube. All right. So two like terms can be simplified further in terms of their addition and subtraction. Okay. So with this remark, let's try to see if we are able to identify if the given set of terms represent the like terms or not. Now, this example is a really simple set of example, right? One-liners, and I'm not going to use the board to show you the solution. Instead, we can communicate via the chat box. All right. I'm going to answer the first question, and then I want you guys to write down the answer for the next sub problems as I ask them. Right. So let's start with the first pair. Look at the first pair. 9x cube and 4x cube. Do they represent like terms? Well, I need to check two things. Number one, do they have the same variable? Well, variable is x in both terms, so they have the first feature matching. The question is, do they have the same exponent as well? Looks like the exponent is the same as well, right? So both of them are matching. They have the same variable, they have the same exponent, meaning these two terms, they are the like terms. All right. Now, question for you. Does the second example represent the like terms or they are unlike terms? All right. Again, two questions you would like to ask. Do they have the same variable? Well, check the variable part, right? Variable in the first term is P, variable in the second term is Q. They are not the same, so these are unlike terms. All right. So again, these two terms, they are unlike terms. Why? Because they don't have the same variable. Okay. Now question number 3. Does this pair represent set of like terms? or does it represent set of unlike terms? Now this example is somewhat tricky, all right? Why is it tricky? Let me explain you. The first term, it's clear that 9 is the coefficient, a is the variable, 3 is the exponent. In the second term, the exponent with the base is sitting in the denominator. This is the reason why I said it is little tricky. Okay. What I want you to do is recall. How do you shift the denominator in the top? Well, if you shift the denominator in the top, you need to flip the sign of the exponent, right? So this term is basically same as 7 times a to the power positive 3. All right. So once again, this second term can be rewritten as 7a cube. All right. Now you ask those two questions. Is the variable same in both terms? Well, variable is a in both terms. So that first feature is matching. Is the exponent same in both terms? Well, here the exponent is 3. Here the exponent is 3 as well. They represent the like terms. All right. So again, understand that for like terms, we just want variables to be the same, exponents be the same. Okay. All right. How about the last one? Well, for the last one, looks like we have the same variable. So variable is matching. Do we have the same exponent? Answer is no. Here the exponent is 5. In the second term, exponent is 4. That means these two terms, they are unlike terms, right? So again, it's literally like one line argument for each one of them. Okay, like terms, second one is unlike terms, third one is like terms, fourth one is unlike terms. All right. So now we know how to identify the like terms. We know how to identify the unlike terms. So now I have one more interesting question for you. All right. And here is that question. Think about it. What do we get if we add n plus 1 unlike terms with natural powers together in the same variable? All right. Again, what do we get if we add n plus 1 unlike terms in the same variable with natural exponents? All right. So this is how I want you to say it. Let's say you have first term a times x to the power n. The second term is b times x to the power n minus 1. Third term is c times x to the power n minus 2. And let's say you keep going in this way. All right. What I want you to do is add all the unlike terms. Remember, like terms can be simplified further in terms of addition and subtraction. Unlike terms, they cannot be simplified further. What I am asking is, what do you get if you add n plus 1 unlike terms in the same variable? Answer to this question is we get the expression called polynomial. All right. So again, here is the formal definition of a polynomial. A polynomial in variable x is an expression of the form an x to the n plus an minus 1x to the n minus 1 plus an minus 2x to the n minus 2 dot 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 a1x plus a0. All right. Look, these are n plus 1 terms. First term, second term, third term, fourth term, so on. This is nth term and this is n plus 1th term. All right. So we have this n plus 1th term, n plus 1 terms in the same variable added together, and the result is called the polynomial. I'm very sure that most of you must have seen this definition in the past, maybe in a different way. This is the most logical way to introduce such definition. All right. Okay. Now, polynomials are identified by their degrees. All right. Polynomials are classified by their degrees. In fact, let me tell you here that there are two terms that are most important terms here. If you want to learn about polynomial, you only need to know two terms from that long expression. Let me tell you what are those two terms. The term that has highest power of x in it, and then the term that has zero power of x in it. All right, remember, zero power of the variable, zero power of anything is 1, right? So that last term can be seen as coefficient times x to the power 0. All right, what I am saying here is the entire polynomial's behavior can be understood using only two terms, the highest x power term and then the term that doesn't have x in it. I would like to give these two terms a name. All right. Most of the names in mathematics, they are given logically. If you understand logic behind it, the word will be crystal clear in your mind forever. All right. Let's see. This term, it's a dominating term, highest x power term. All right. It's a leading term. All right. The highest x power term, it's called the leading term. All right, this is the term that leads the entire polynomial. It's a dominating term. Okay, the term that doesn't have x in it, we call it constant term. All right, so two important terms that allows us to, those of you who have taken college algebra course, they know how to plot the graph of the polynomial function using the leading term and the constant term, right? Endpoint behavior can be also investigated using these two terms only, right? And this is the main reason why we are talking about these two terms. If you haven't seen this idea before, don't worry about it. We are going to discuss functions in detail very soon. All right. So for now, let's not use the word function. I'm going to use the word polynomial for now. And polynomial, its behavior can be investigated using only two terms. That highest x power term, I'm going to name it the leading term. All right. And then that term that doesn't have x in it, I call it the constant term. All right. Constant term means no variable. Okay, or variable to the power 0 is there. Okay, all right. The coefficient in the leading term, an, we are going to name it the leading coefficient. That n, the highest power of x, it's called the degree of the polynomials. Let me tell you that polynomials are classified by their degree. Like numbers are classified by their value. If I give you two numbers, 3 and 5, you would immediately say that, oh, 5 is bigger than 3. So this is what we mean by numbers are classified by their value, right? Same way, polynomials are classified by their degree. So if I give you two polynomials, let's say x cubed plus 2x plus 5 and 3x squared plus 4x plus 5, and I ask you to compare these two polynomial, which one is bigger, which one is smaller, you are going to decide that using the degree of the polynomial. All right, so this is kind of a cool way to identify a few things. Anyways, let's put these remarks together. As I said, this an x to the power n, I would like to call it the leading term. This is the term that leads the polynomial. Highest x power term with the sign, that is our leading term. Okay. An is called the leading coefficient, n is called the degree of the polynomial. All right. A0 is our constant term, and then I also mentioned that polynomials are classified by their degrees, and then we can understand the behavior of the polynomial using the leading term and the constant term. So this is really something that is already known to us. So you see how nicely we are into the discussion of polynomials now. Now let's try to see few illustrations carefully. If we can able to identify these two important terms and its pieces, leading term, constant term, degree, and leading coefficient. Let's see if we can identify them in the following set of examples. Again, because this is really like one line work, I don't want to use the board. Instead, we can discuss these examples in the slides. All right, let's start with the first illustration. I give you this polynomial x to the 5 plus 5x squared plus 7x plus 3. What you need to do is give me the leading term, leading coefficient, degree of the polynomial, and the constant term. These are the four things we would like to find out. Okay, so first let's find out those two terms, leading term and the constant term. The highest x power term in this polynomial is this x to the power 5. This is the leading term. All right, what is the constant term? Well, constant term is 3. Okay, all right, from the leading term, what is the leading coefficient? Looks like there is nothing multiplied with x to the 5, so 1 is what we assume, right? So leading coefficient is 1. What is the degree of this polynomial? Well, degree is 5. Okay, so again, I identify the leading term and constant term first, and then looking at the leading term, I classified what is the leading coefficient and what is the degree. Okay, all right, let's repeat this in the second example. Can you identify the leading term? Well, leading term is the highest x power term with appropriate sign, right? Positive 3x to the 7 is the leading term. What is the constant term? 20. What is the leading coefficient? Leading coefficient is 3. And what is the degree of this polynomial? Degree is 7. All right. Let's do it one more time for number 3. Can you identify the leading term? Well, leading term is negative 7x to the 9. Constant term is 300. Leading coefficient is negative 7 and degree is 9. All right. Let's see one tricky example. The last one, little tricky. The leading term is negative x to the 9. Leading coefficient negative 1. Degree 9. What is the constant term? Well, it doesn't look like there is a constant term there. So we can say constant term is 0. All right. So again, if I give you a polynomial, understand that it is easy to find out these two important terms, right? Leading term and the constant term. Using the leading term, we can find out the leading coefficient and the degree of the polynomial. Okay, so this is really a very simple set of examples, and as I said, we don't really want to use board for this one-liners. Fairly easy deal. If you understand those remarks, this is super simple question, right? Now here is more interesting question. What sort of operations can you perform if you are given two or more polynomials? Again, let me make that question simple for you. If I give you two numbers, let's say 2 and 5, all right? The question is what type of operations you can perform on these two numbers. The answer is very simple. You can say I can add these two numbers. I can subtract them in any order I like. I can multiply these two numbers and I can divide these two numbers. All right, so these are four basic operations that we can do with the numbers. Now think about it. What are the outcome of this process? Well, if you add these two numbers, right, 2 plus 5, what is the result? Result is a brand new number. Again, result of this operation is a brand new number. All right, if you subtract them, 2 minus 5, that is negative 3, or 5 minus 2, positive 3, the outcome is a number, right? If you multiply them, 2 times 5, 10, brand new number. You see, if you divide them, 2 over 5 or 5 over 2, brand new rational number, right? So if you apply these basic operations on numbers, the final outcome is going to be a brand new number, right? The question is this: if I give you two polynomials, would you be able to add them, subtract them, multiply them, and divide them to get a brand new polynomial as a result? Understand that we are trying to create a theory parallel to the theory of numbers. This theory of numbers is very well known to us. In fact, we have been using this from last many years, right? Can we do the same thing with polynomial to produce a new polynomial as a result? Answer to all these questions is yes. We can add two polynomials, we can subtract them, we can multiply them, and we can divide polynomial by polynomial. Kind of a cool thing, no? Now, the first thing first, I would like to show you how to add, subtract, and multiply two polynomials first. And once we have that idea, we will talk about division of two polynomials. Okay, so let's start with these three processes: addition, subtraction, and multiplication. In order to begin the example, I would like to remind you two basic rules from the past. The first rule is called property of exponent. All right, and this is fairly simple. If you have two exponents sharing the same base multiplied together, then this is how you simplify it. Keep the base same, add the powers. Okay, if I ask you to multiply x cube with x to the power 2, all you have to do is, keep x as a base, add the powers. 3 plus 2, 5. So x cube times x square is x to the 5. X to the 1 times x to the 1 is x to the 1 plus 1, or x square. All right, so this is a simple rule that most of you have been using frequently, right? So this property is called property of exponent. The second property that I want you to recall is called distributive property. If you have a factor multiplied by sum of terms, you can distribute this factor over every single term of the next expression. Look, a times b plus c is a times b plus a times c. So a is being distributed over both terms. Okay, so again, to understand addition, subtraction, and multiplication, you really need to know these two rules. And once you have these two rules with you, we should be able to perform addition, subtraction, and multiplication of two polynomials. So this example number 4 and 5, I would like to show them on the board, right? So let's start with number 4 first, which basically describes how to add and subtract two polynomials. All right, so here is number 4. I'm going to write down both sub-problems side by side. The first one asks us to add two polynomials, 3x squared minus 4x minus 12 plus 4x squared minus 3x plus 7. And then part B asks us to subtract two polynomials, x cubed minus 5x squared plus 11x minus 2x cubed minus 7x squared minus 5x plus 4. All right. Let's carefully try to add and subtract these two polynomials. Okay. As I said, this is sum of all unlike terms. I can't simplify this any further. This is also sum of three unlike terms. All right. I really need to open the parenthesis first. So opening the parenthesis requires you to distribute 1 over all these three terms. If you open the parenthesis, you are going to get this long expression with 6 terms. Now check if you have like terms there. Remember how to identify the like terms? They must have the same variable, same exponent. Check it. Look, 3x squared, 4x squared. These are the like terms. I would like to put the like terms together. So with their appropriate sign, I'm putting the like terms together. I know that most of you can skip this step. Absolutely fine to skip it. Because this is the first example, I would like to show you systematic computation. All right, so I'm putting all the like terms together. Negative 4x, negative 3x. And then the constant term, negative 12 plus 7. Remember, like terms can be simplified further in terms of their addition and subtraction. Add them like how you add two numbers, 3x squared plus 4x squared. Add them how you add 3 and 4. It's 7, right? So you get 7x squared here. Negative 4x, negative 3x. Add them how you add negative 4 and negative 3. It's negative 7x. And then negative 12 plus 7, negative 5. Look, subtraction of two polynomial, addition of two polynomial result into a brand new polynomial. All right. So think this thing as one way to produce a brand new polynomial as a result from the given two polynomials. Fairly easy deal, no? As I said, I know most of you can skip this third line. Absolutely fine. You don't have to write like terms next to each other to simplify it further. You can just see it from here. 3x squared plus 4x squared, that's 7x squared. Negative 4x, negative 3x, that's negative 7x. Then negative 12 plus 7 is negative 5. Perfectly fine to skip one line. I'm going to do that in that next example. I need to subtract two polynomials. Let's open the parenthesis first. The first expression has 1 outside, So when I open the parenthesis, all the terms will stay the same. All right. Now, that negative sign means you have to distribute that negative sign over every single term, meaning multiply every single term in the second parenthesis by -1. The sign will be flipped. -1 times positive 2x cubed is negative 2x cubed. -1 times negative 7x squared is positive 7x squared. -1 times negative 5x is positive 5x, and -1 times positive 4 is -4. Now do the same thing. Find out if you have set of like terms and simplify them further. Okay, so I got 2x cubed terms. Add them, x cubed minus 2x cubed. That's -1x cubed. 5x squared, -5x squared plus 7x squared. That's 2x squared. And then 11x plus 5x, 16x. There is only one constant term, and that will stay. This is sum of all unlike terms. Third degree polynomial is the final outcome of this process. We can create more fancy examples. Again, as I say, these are demonstration problems only. Let me give you one quick fancy example which may help us for the next idea. Let's say I have 7 times x squared minus 3 minus 4 times 2x squared plus 3x plus 1. We again do exactly the same thing. Distribute that 7 over 2 terms, -4 over these 3 terms, open the parenthesis, collect the like terms, simplify as much as possible. Let's do it. 7 times x squared, 7x squared, minus 7 times -3, -21, -8x squared, -12x, -4. Simplify the like terms. Look, 7x squared minus 8x squared, -x squared, -12x, -25, and done. All right. So again, pretty simple idea. There is no trick in any of these examples. Let's end this discussion with this fifth and final problem, where I want to show you how to multiply two polynomials. Let's try it. All right, so here is example number 5. We would like to multiply 3x minus 5 with 4x minus 7, and we would also like to multiply 2x minus 3 with 4x squared minus 5x plus 6. Okay. All right. Let's try to multiply two polynomials now. We realize that addition and subtraction, they are super simple deal. All right. How do we multiply two polynomials? I want you to recall that distributive property. Remember, look at this portion, 7 times x squared minus 3. What did we do to simplify? Well, I distributed 7 over first term over the second term. Right? So this is what I have done to simplify that. I want you guys to see this example in the same way. A factor multiplied by sum of terms. All right? So I want you to think that 3x minus 5 as a 7. Right? So again, think this thing as a 7. 7 times 4x minus 7. How do you handle it? Just distribute that 7 over both terms. Want you to do it with 3x minus 5. Look, I'm distributing 3x minus 5 to 4x and then 3x minus 5 to 7. Again, simple deal, no? I did exactly the same thing that I did in that previous example. Distributed this factor over 4x over 7. All right. Now this portion should look like the distributive property again 2 times. Look at that. All right. So first I distributed that first entire factor over 2 terms of the second bracket, and then I realized that I have to do this distribution 2 more times. Let's do it. 4x times 3x. 4 times 3 is 12. X times x is x to the 2. 4x times negative 5. 4 times 5 is 20, and then x. And then there was a negative sign there. Negative 7 times 3x, negative 21x, and negative 7 times negative 5, that's positive 35. If there are like terms, you would like to simplify further. Okay, so look at this. I have 2 like terms. Simplified 12x squared minus 41x plus 35. This is the sum of all unlike terms, and that is our final answer. Right? Not so bad. Many of you may have heard about the FOIL method. Let me show you the same computation using the FOIL method as well. You don't have to use both methods. All right, you can use one or the other. You can either use the first method or the FOIL method. Let me tell you what is the FOIL method. FOIL method basically allows you to perform distributivity simultaneously on all the terms. All right, so this is what it does. You take the first term from the first parenthesis, multiply it by the both term in the second parenthesis, and then you take the second term from the first parenthesis, multiply it out with both term in the second parenthesis. This idea is called FOIL method. All right, let's do it. 3x times 4x. Product of 3 and 4 is 12. Product of x with x is x squared. 3x times negative 5, negative 15x. 4x times negative 5, negative 20x. Negative 5 times negative 5, positive 25. All right. If you have like terms, you would like to add them. Look at this. 12x squared minus 35 of 4x minus 7. Oops. Okay, so 12x squared minus 21x minus 20x plus 35. All right. 12x squared minus 41x plus 35, and that's what I get. Again, if you see logically, these two methods, they are exactly the same thing. All I did is I skipped that intermediate step. It's perfectly fine if you want to do it in this type of example. All right, so you can use the FOIL method to eliminate one step from the computation. All right, do distribution simultaneously. Can we do the same thing in here? Answer is yes, we can do the same thing in here. Look, A times B plus C plus D. It should look like this term. How you distributed 4 over all these 3 terms? Need to do the same thing with that first factor. Let's do it quickly. All right. I'm going to distribute 2x minus 3 over 4x squared, negative 5x, and then over that 6. Let's do distributivity 3 more times. Right? 8x cubed minus 12x square minus 10x square plus 15x plus 12x minus 18. Like terms should be simplified further. I end up getting 8x cubed minus 22x square plus 27x minus 18. As I said, you may wonder that can we use FOIL type of method for this example? Answer is yes. It's just the same logic, right? Let's end this idea with this final computation. Look, 2x minus 3, 4x square minus 5x plus 6. This is what I would like to do. First term from the first parenthesis should be multiplied with all three terms from the second parenthesis. And then this term should be multiplied with all these three terms in the second parenthesis. Basically, we are going to skip one step. Look at this. 8x cubed minus 10x square plus 12x minus 4 minus 12x square plus 15x minus 18. If you take care of like terms, you're going to get 8x cubed minus 22x square plus 27x minus 18. In other words, you will get exactly the same result. Okay, so looks like we are running out of time. So let me stop here. This is a good point to stop.